Week 5, lesson 6. Okay, so this lesson is almost, it is so unbelievably close to the last lesson that we did. So week 5, lesson 5 was on doing binomial distributions. This is also binomial distributions. It's just sort of bumped up a level, all right? So that's why I gave you the last lesson, to sort of remind you how you did it last year. You have the option of sort of falling back on this, but this, if you know how to use your calculator, and that's going to be part of this lesson, can make it so much easier. So there are some conditions. These are the same conditions from the last lesson. You can read those. This, and I know it looks really complicated, but I promise you it's really not. This is how you're going to fill in every one of the blanks, right? So on the last lesson, right, you had to fill in every blank and there had to be a number. That's this. You had to have a probability of one of the things happening. That's this. And then this is the probability of it not happening. And if you remember, each of the exponents in every blank had to add up to be 1. Well, not 1. Add up to whatever the total number was. And that's going to happen here as well, because the k and the n minus k are also going to add up to be n. All right, you're going to see some new notation here. So you'll see me use this in just a little bit. And it's also what you're going to need when you go to use your calculator. All right, so go ahead and read this problem. A mailman delivers packages 7 days a week. Probability that the package is delivered by 9 a.m. is 0.7. So the notation that you're going to see here is that it's a discrete random variable. Sorry, that should be a squiggly line. The 7 is the number of days per week. It's the n. And then the probability is 0.7. All right, so you could do this the way you did it before, where you're filling in the blanks. We're just going to go ahead and immediately go to a probability distribution, however. So I have typed it up because it's fairly lengthy. There it is. But take a look. This is literally the same thing as having 8 blanks, right? There are 8 blanks because this number here is a 7. Okay, that's why there's 8 blanks. You can count them. There are 8. Every one of those blanks has a number, all right? It has a number that you're going to get by doing a combination. This is the number. It's the same number that you would get if you use Pascal's triangle or if you use the pattern. Okay, the first number that you're seeing here is the probability of it being before 9 a.m. Okay, and notice that you can see the exponents are rising on that one. Okay, and then this is the probability of it not being before 9 a.m. And each of those is the probability, or the exponent is descending. All right, and you could break out your handy dandy calculator and figure out each one of those. I am going to fill those in right now, just like that. And now that it's filled in, that's part A, right? I just did part A. I should be able to now answer these questions. So what is the probability that a mailman delivers before 9 a.m. exactly 5 times? Okay, so exactly 5 times. On time, exactly 5 times. I believe that happens right here. Right, if you look right here, this is on time 5 times, so that answers 0.318. And then for part C, delivers before 9 a.m. at least 5 times. So that happens, what, here and here and here, right? This is 5 times, this is 6 times, this is 7 times. And if you add those 3 decimals up, we should get 0.647. Okay, so for the next example, you are going to be able to fill all of these in. Oh, I should have grabbed a highlighter. Anyway, all of these numbers in without even needing the calculation above it. Your calculator will fill those in for you as long as you use the right buttons and you know which direction you're going. So let me kind of write down the things you're going to need, and then I will show you on the calculator. So if you use a button that looks like this, it says Binom PDF. this is going to give you an exact probability, right? So it'll give you like this one number, depending on the numbers that you plug in. Whereas if you do binom CDF, it's going to give you a range of values. So like on this problem that you're looking at, if we wanted 4 days or less, right? If you want all of these numbers, this would be the button that you would push. It'll compute the sum and everything for you instead of having to do each of them individually and then add them up. Now, the most important part about that particular button is that it calculates in this direction. It calculates from 0 up. Okay, so if you want, let's say, these 3 numbers added up, it's not going to do that for you. What you're going to have to do instead is calculate these numbers and subtract from 1. Okay, again, the calculator is always going to calculate from 0 upward. Okay, so at the top of this page, you're seeing a couple new calculations that you're going to be able to use. If you want to do the expected value, all you're going to have to do is multiply n times p, and if you want the variance, it's n times p times the 1 minus p. Okay, so it makes it really, really easy, and I will cover an example. All right, so for this particular problem, if you are reading, it is going to be a discrete random variable with a binomial distribution. She's coming home 5 days a week, and the probability that she gets to watch SpongeBob is 0.4. Okay, so with these numbers and the calculator, I'm going to be able to fill in this probability distribution. Okay, so let me show you how to use your calculator to fill in that probability distribution. So you need the one that says binom PDF, which is going to be here in this little distribution menu. So to get there, you're going to have to hit the blue button right the second, and vars, which gets you this distribution menu. And you're going to have to scroll down until you find the one that says binom PDF. That's the one. Okay, so you go ahead and enter. And then it's asking you, okay, so how many trials are you doing here, right? What's the maximum number of times? And for this SpongeBob problem, it's a 5. And then you're going to hit enter. Okay, then it says, okay, well then what is the probability for each of those trials? And it's 0.4. So then the x value, right? So there's going to be 5 different x values that we're going to be plugging in, right? The first one we're going to plug in is a 0. All right, so then we scroll down and you hit paste. Okay, so now it's saying these are the numbers that you are going to be plugging in, right? There's 5 times that this person's coming home trying to watch SpongeBob. The probability of it happening is 0.4, and we want to fill in the chart for 0. So when you hit enter, there's the first probability that you're going to be putting under the 0. Okay, so now instead of retyping that in every time, check this out. If I just go up a couple times, it highlights, and if I hit enter, I get those exact same numbers, because really the only one I need to change if I go left is change that 0 to a 1, and now I get the next number in my chart. And again, I can continue to highlight, enter, and go, I highlighted the wrong thing. Hold on, let me see if I can get down there. I need to clear that out. Let's clear that. There we go. Okay, go up, highlight, hit enter, go to the left, change that 1 into a 2. All right, so again, you're just filling in the chart as you go. And if you fill it all the way in, it will end up looking like, and now that it's filled in, I should be able to answer some of these questions. So let's see, question A, on 3 days, exactly 3 days is 0.2304. For B, at least 3 days. So that's going to be 3 days or 4 days or 5 days. And if you add those up, you will get 0.3174, right? Or, right, just keep in mind your option also, if you just have your calculator, you could do 1 minus the probability that it's less than or equal to 2, right? Which means you're calculating these 3 all at the same time, and then you're finding the complement. Okay, for part C, where it says at least 3 days which are consecutive. Okay, so that means it could be successful, 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 fail, fail. It could be fail, successful, 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 fail, or fail, fail, success, success, success. Right? Keep in mind, there's 5 days of the week. We want 3 of them to be consecutive. So it could be Monday, Tuesday, Wednesday. It could be Tuesday, Wednesday, Thursday. Or it could be Wednesday, Thursday, Friday. All right? This is, again, a probability. So we need to figure out how many ways you can pick 3 days out of 5 days. So the top is 3. The bottom with your calculator is 10. Okay, so what this means is this is 3/10 times the answer to part A, right? The answer to part A was exactly 3 times. So if I multiply this by 2304, we get 0.06912. Okay, let me scoot this up a little bit. All right, the expected value for part D, we have a brand new formula, right? We just have to do n times p. In other words, 5 times 0.4, which gives you 2. And then part E, it wants the standard deviation, which is just the square root of the variance. Now, luckily, the variance calculation is really easy. It's going to be 2 times 1 minus the 0.4. That's my dog shaking his head. Sorry about that. That's 1.2. Square root of that in order to get the standard deviation is 1.10.